Okay, so now we're talking about inverse trig functions. One thing you want to be careful of, and some of you are going to make the mistake, I hope not, but usually people do, is this notation can get confusing. They think of it as a reciprocal, and that's not what it is. It's actually saying arc sine. I had an exchange student from China a few years ago at Oxbow, and he said they don't use this notation in China. They only use arc sine, arc cosine, arc tangent. So just keep in mind, this doesn't mean reciprocal. So now we'll go on. So you spent some time in chapter 5 thinking about evaluating sine and cosine, tangent, cosecant, secant, etc. And some of you probably picked up that, oh, I can just use a unit circle for some of these values, and this says what's the sine of pi over 6? Well, pi over 6 is the same as 30 degrees, and we know that x, if this is the unit circle and this is 1, we know that x over 1 will be the cosine, right? X over adjacent over hypotenuse will be cosine, and y over hypotenuse will be sine, and so we know each one of these, the x value is the cosine, the y value is the sine. So what's the sine of pi over 6? Well, it works out that it's 1/2. Then it says, the inverse of that says, okay, so what angle gives me, has a sine of 1/2? So we could think of this as, what's the sine of some theta? When is that equal to 1/2? Well, we can see right here, right back where we were working on it, that it's going to be pi over 6. And that makes sense because they're inverses, right? They undo each other. But then what comes up is, I see another place over here where sine of y equals 1/2. Or the sine of the angle. Sine of 5 pi over 6 is also equal to 1/2. So which is it? I got two outputs for a single input, right? But this, I could go around again, and that would be what? That would be 7 pi, that would be 13 pi over 6. That would also be, and then I could go over here, and that would be what? That would be 17 pi over 6. And I keep going. So what I've got going on is I've got a single x. A single input can give me more than one output. So that implies that the arc sine is not a function. And that's true with arc cosine, arc tangent, arc cosecant, arc, etc. So let's talk about how to fix that. So then what we have is, this is a handout that I use from another Stu Schwartz. He's a retired math teacher. He does a great job with this stuff. And he starts talking about inverses. You can read this if you want. And talks about inverses are reflected around the line y equals x. So here's the sine x. Here's the graph of sine x. And then here is this reflected around that line. Or maybe even better, the better way to think about it is if this is y equals sine of x, this can equal to x equals the sine of y. And that's that inverse. And of course, that fails the vertical line test. And that's what we were seeing back on that unit circle thing, where I knew that pi over 6 and 5 pi over 6 and so on and so forth all yielded the same value. So what we try to do is we try to limit, what we do is, in order to make the arc sine be a function, we limit the possible inputs. So it's a section of just that passes the vertical line test. And you can kind of see this here, but it's kind of lame. So what I drew it out in Desmos, and what you see, here's the line, here's the curve, x equals sine y, and then this blue part here, let me see if I can't get fancy. This blue part here is the actual graph of the arc sine. And notice I highlighted these points because that's the end point. That's where we say those are the limits of the domain, and I'm only going to be concerned about getting output on that range. So let's think about what that range means. That range means, okay, here, let me go back to, if this is the unit circle, I'm only looking at output from -1. Remember, we're talking about we're talking about switching x and y. I'm going to do this if it's the unit circle. Negative pi over 2 has a y coordinate of negative 1, sorry. And positive pi over 2 has a y coordinate of positive 1. So when you're dealing with the arc sine function, you're going to input numbers from negative pi over 2 to positive pi over 2 and get output of between negative 1 and positive 1. And notice, I'm sorry, you're going to input negative 1 to positive 1 and get output between negative pi over 2 and positive pi over 2. And you can see that here, right? If that's my input, then here's my output. So that's going to be negative pi over 2. That's positive pi over 2. Okay, and of course that's where the 1 and negative 1 is. And what that means, it's always going to get output in quadrant 4 or in quadrant 1. So you've got to keep that in mind. The easy way to think about it is if I have a negative value. So if I'm going to find the arc sine, I might have this in the next slide. If I'm going to do the arc sine of negative 1/2, well, that's a negative. I'm putting in a negative value. So that's going to be, if you think about this graph, right? If I'm putting in negative 1/2, my y is going to be a negative value. And that's what you can think about here. Well, if this is let's see, what am I right? Negative 1 over 2, that's going to be negative pi over 6 or negative 30 degrees. Okay. You won't worry about the angle over in quadrant 3 because we just can't look in those outputs. Okay, maybe we should do some examples and get on now. We've got this theory done. The same thing happens with cosine, and you're not going to have a blank page in your notes, but with cosine, let's see. What happens with arc cosine, you get output between 0 and pi. That's where your output's going to be. And again, you're going to be putting in what are we going to be putting in? We're going to be putting in negative 1 and would get pi, and then would put in positive 1 and get 0. So that will be our output there for our cosine. It always lands up here in quadrant 1 and quadrant 3. And then if you look at that graph right here, do you see, I don't know if, let me try to zoom this in a little bit. So this is the graph of all these lines here. Here, let me etch these out. That line, there, that curve. There aren't lines. Those are all x equals tan y. If I were to graph x equals tan y to get all those lines. So, but we want just to pass the vertical line test. So we limit the output from negative pi over 2 to positive pi over 2. So unit circle, thinking about it, arc tangent will give us input or output the same place, same quadrants that tangent will, or sine will, okay? And notice cosine gives us output between 0 and pi. Okay, so I think the best thing to do is to go ahead and do some exercises here. And Stu Schwartz gave us these 30, 60, 45, 45 triangles to help you out. You can just use a unit circle if it's a unit circle question. I honestly don't usually use a unit circle. I usually think about it this way. So we already did this one. Well, we did we negative 1/2? Yeah. So we know arc sine is, well, if we look at this, what angle has a sine? A positive 1/2. Well, if I look at this 30, 60 right triangle, I see 1 over 2 is 30 degrees, or pi over 6. But because this is negative, our output comes out down here in quadrant 4. So the answer is going to be either negative 30 degrees if you're working on 0 to 360, or it'll be negative pi over 6 if you're working 0 to 2 pi in radian measure. Okay? So there's that one. How about we skip over the B for a minute? Let's do this one. This says, what angle has a tangent of the square root of 3 over 1. Well, if you look back at this 30, 60 right triangle, opposite over adjacent would be root 3 over 1. That's going to give me a 60-degree angle, and is positive, and I know that arctangent gives me output in quadrant 4, quadrant 1, and it's positive, so it's got to be up here in quadrant 1, so we'll use 60 degrees or pi over 3. Okay, let me stop this video and clean it up a little bit, and we'll do these other ones here. Okay, for the arc cosine of 0, how do we do those ones? Because I don't see 0 on these, either one of these graphs, or either one of these tables, or either one of these triangles. So then you got to think about these coordinates. And then you also got to remember that x is the cosine, y is the sine, and then tangent's going to be the ratio of those. And cotangent will be the reciprocal ratio. Cosine, sine. So cosine of 0. So this says, what's some angle? Some angle has a cosine is equal to 0. So some angle has a cosine where has a value where the x coordinate is 0. Well, if we're looking at this, we see two places. I see a point right there with the x 0, and I see another point here with the x is 0. Our cosine, remember, has output in quadrant 1 and quadrant 2. So the only possible answer we can say is 90 degrees, or we can say pi over 2. Okay, and this will work, and this works for any of the times with 1 or 0 or undefined. What if I said, what's the arc secant of undefined? So we know that one's going to be where 1 over the cosine is equal to 1 over 0. Well, when's the cosine equal to 0? Well, we just answered that at pi over 2. You aren't going to see arc secant in this course too much. Calculus, they'll throw it at you a little bit, but it'll be really, you'll have enough tools so you won't have to think about it too much. It might be more Calc 2 where you see it. Anyways, let's do this last question, then we'll move on down the road a little bit. So this is asking me to find some angle that has a cosecant that's equal to negative root 2 over 2. Well, I don't know. Cosecant's kind of confusing, so I'm going to rewrite it in terms of sine or cosine. So I know 1 over sine is cosecant. So basically what I'm asking is I'm trying to find the arc sine of 1 over negative root 2. Well, I notice that it's negative, so I know my output is going to be down here in quadrant 4. Then I see 1 over root 2. Well, let's see. If here's an angle, here's the triangle, the values that have root 2's with them, and sine is going to be 1 over root 2, so I know it's going to be a 45-degree angle. It's just got to be a negative 45 degrees, or a negative pi over 4. Okay, so that's how you deal with the reciprocal functions. Rewrite them in terms of sine or cosine or tangent, and then you can take it down the road from there. So everything we've been working on up to now has basically been a unit circle kind of question. So what they're doing to us, and also what's different with this, is they're giving us a composite function. So what we're going to do is we're going to just start on the inside and work out. So I know the arctan of 3/4. Well, I don't know. That's telling me I'm looking for a function or an angle that has the tangent of equal to 3/4. Well, I don't know what that is, and I really don't want to find it. And that's the beautiful thing about this. And you'll see down here in example 3 why that's important. So if this is my angle, and I know the opposite side is 3, the adjacent side is 4, If I wanted to find the hypotenuse, I could use the Pythagorean theorem. Maybe you remember 3, 4, 5 triples. So that would tell me it'd be 5. If I didn't remember that and had to use the Pythagorean theorem, 3 squared plus 4 squared, then take the square root, well, you're going to get 9 plus 16. 9 plus 16 is 25. The square root of 25 is 5, okay? So what's the sine? So now we've all that. We've got the triangle all set up. We took care of the arctan of 3/4. I don't care what the angle is, because all I'm going to do now is find the sine of that angle. So what's the sine of this angle theta? Well, I see 3/5. Okay, pretty easy. Let's do C, just because it's not a unit circle kind of problem. So I'm going to start inside. I'm going to say the sine of some angle equals 1/3. So here's my triangle. I know the opposite side is 1. The hypotenuse is 3. The other side is going to be 3 squared. So remember, if you think about a squared, I do this out this way because some people don't know what I'm talking about when I write it this way. If I had to solve that for b, wouldn't that be the square root of c squared minus a squared? So c squared is 9, a squared is 1. So won't that be the square root of 8? And yes, you could simplify it, but for this one, it's easier not to. And then now they're asking me to find the secant of that. Well, secant is a reciprocal of the cosine. The cosine would be √8/3, so we'll write it as 3/√8. And then, of course, if they want us to rationalize it, I'll just multiply by √8/√8. So 3 square roots of 8/8, and that doesn't simplify. I mean, I guess I could. I could take out, this is 4 times 2. That would be 2 square roots of 2/8, and then the 8 cancels out with the 2. So we could simplify this to 3 square roots of 2/4. Okay, now we get it abstract. You will be using this in Calc 1 when you talk about derivatives of inverse trig functions. I still think it's good to do it this way, because this way you don't have to memorize another formula. So, but it's the same deal as we just did. I'm going to say, okay, so I've got the sine of some angle has to equal to x. And of course, opposite over hypotenuse would have to be x/1. So let's draw that triangle. Let's see. Here's my theta. Here's my angle. This is x. This is 1. And this side will be, well, if I were doing the Pythagorean theorem, which is really what I'm doing, I'm going to say c squared, which is 1, minus x squared, which is a, and then I'm going to take the square root, and that'll be how big that that adjacent side is. No, maybe I should write this out. I know that x squared plus b squared equals 1 squared, right? And then if I subtract b squared, so x squared, I mean 1 minus x squared, then I take the square root, I get that. Just in case I'm going too fast. So then we ask, what's the cosine of this angle? Well, the cosine of this angle is going to be the square root of 1 minus x squared over 1, which we could write it that way. So that's what that becomes. Okay. So now, let's see, let's do the rest of these. So I've got the cosine of some angle has to equal x. Well, this looks familiar. x/1. But now we're talking about this side and this side. And this side will be the 1 minus x squared, right? Square root of 1 minus x squared. So what's the tangent? Well, that's going to be the opposite side over the adjacent side. How about this one? So the cosine of some angle equals 2x/1. So here's my angle. Adjacent is 2x. The hypotenuse is 1. The other side will be 1 squared minus 2x squared, which is 4x squared, right? Remember, we're going to square the 2 also. And then what's the sine of that? Well, the sine will be, here, let me erase this here. Probably should have deleted that. I was trying to be lazy. So the sine will be the opposite, which is 1 minus 4x squared over 1 if you want, and that's that. And then we'll do d, which is kind of interesting. So tangent of some angle is equal to 3x. So over 1, right? So the opposite side is 3x, the adjacent side is 1. And in this situation, we're going to square both of these and add them. So 9x squared plus 1, and I take the square root, and then we're looking for the sine. Well, won't that be 3x over the square root of 9x squared plus 1? And that's what that becomes. And that's about it. This is as hard as it gets. You're going to be doing some word problem kind of questions. Here, let me add a blank. It'll tell you this kind of thing. Here's a triangle. Let's suppose they'll tell you this is 5 and this is 4. They won't be that easy. They want you to solve this triangle. Well, I need to find 2 angles. I also need to find a side. Well, the side's easy enough because that's the 3, 4, 5 triple. If it weren't a triple, you'd have to say 5 squared minus 4 squared and take the square root, right? But then to get the other side, so if this is angle A, how big is angle A? Well, I see an opposite, I see a hypotenuse. So I know the sine of angle A equals 4 over 5. Well, how do we find an angle if I know the sine of it? Well, we'll do the arc sine of 4 over 5. And of course, that's not a unit circle problem. So we got to grab a calculator. Let's see, where's my calculator? Make sure you're in degree mode. Yeah, I'm in degree mode. Whoops. And it'll do second sine. Second sine, you can type in on the Google calculator, you can type in arc sine, the word arc, A-C-A-R-C, you can write this right in, it'll tell you. You might have to make sure you're in degree mode. Sometimes you can say degrees. So that tells me this angle is 53.1 degrees. And the other one will be the complement of that. So, I could say arc cosine, right? I could say arc cosine of 4 over 5, and that would give me the answer. But I could also just take this away from 90. What's that minus 90? I'm getting 36.7. 36.8. And that's how big this angle is. Okay, so they'll be asking that kind of thing. Something I'm going to do on an exam, I'm going to ask you to find the secant of some angle. How about 17 degrees? How do you do that? I don't have a secant button on my calculator. Actually, you can find this online. You could do it. You could do that. I'm sure that Google calculator will do it for you too. But before we were able to do that, and honestly, I hope you could think this through. Isn't secant the reciprocal of cosine? So I could find the cosine of 17 degrees and then just take the reciprocal of it. So on my calculator, I'm going to just do cosine of 17. And that's giving me 0.9563. And then I'm going to hit the x to the negative 1 key. That takes the reciprocal. So that gives me 1.0457, right? So that's that. We might have done that. This might be a chapter 5 thing. We probably won't. I might ask you to do the arc secant. I don't remember if I was that miserable. But the way you do that, if this were the answer, hit x to the negative 1 key. That'll take you back to here, and then you can just do the arc cosine, right? Arc cosine. And that'll have that answer, and that'll kick you back to 17 degrees. Okay, this video's getting long enough. Give me a yell if you need some help.